Could there be an alien world right here on Earth? It is a place where sunlight has never touched the ground, and the silence is broken only by the quiet hum of existence. This is the deep sea, the abyss. It covers more than half of our world's surface, yet we know more about the craters of the moon than we do about its hidden valleys and mysterious plains. For centuries, it has been a realm of myth and legend, a place where our imaginations have populated the darkness with sea serpents and leviathans. It is, in every sense, the final frontier on our own planet, a vast and enigmatic kingdom waiting to be explored. The sheer scale of it is almost impossible to comprehend. If you were to take the tallest mountain on land, Mount Everest, and place it into the deepest part of the ocean, the Mariana Trench, its peak would still be submerged with more than a mile of water above it. This immense volume of water holds secrets that are only just beginning to be revealed. It is a world operating under rules entirely different from our own, a place of crushing pressure and eternal night. The creatures that live here have adapted in the most extraordinary ways to survive in an environment that we would find utterly hostile. It is a testament to the tenacity of life itself. This deep, dark world is not just empty space. It is a dynamic and living system. There are underwater mountain ranges more extensive than any on the continents, vast canyons that dwarf the Grand Canyon, and volcanoes that erupt with superheated water instead of lava. These features shape the currents and influence the climate of the entire globe in ways we are only beginning to understand. The abyss is not a separate, isolated world. It is intricately connected to our own, a vital part of the machinery that keeps our planet healthy and habitable. Exploring it is not just a matter of curiosity, it is a journey to understand ourselves and our home. For all its importance, the deep sea remains a profound mystery. Each time we send a probe or a submersible into its depths, we are venturing into the unknown. It is like opening a door to a room that has been sealed for millions of years. What new forms of life will we find? What geological wonders await us? What secrets about the history of our planet are locked away in the sediment of the ocean floor? The questions are as vast as the ocean itself, and the answers promise to be just as spectacular. This is a journey of discovery in the truest sense of the word. Since we cannot simply put on a wetsuit and dive to these incredible depths, we have had to invent a new kind of explorer. These are not brave humans in bulky suits, but rather intrepid robots built for the ultimate adventure. These AI-powered submersibles and underwater drones are our eyes, ears, and hands in the abyss. They are designed to withstand pressures that would crush a military submarine and to navigate in total darkness. Think of them as our planet's own space rovers, but instead of exploring the red plains of Mars, they are charting the black plains of the deep ocean, sending back postcards from a world we could never visit ourselves. These robotic explorers are marvels of engineering. They come in all shapes and sizes, from large remotely operated vehicles, ROVs, tethered to a ship by a long cable, to sleek, torpedo-shaped autonomous underwater vehicles, AUVs, that roam freely on pre-programmed missions. The ROVs are our hands-on scientists, equipped with powerful lights that turn night into day, high-definition cameras that capture every detail, and delicate manipulator arms that can collect samples of rock, water, or even fragile deep-sea creatures with surprising gentleness. They are our remote presence, allowing scientists on the surface to walk the seafloor in real time. But the real question is, what secrets does this alien world hold? The answers might shock you. They are sent on long, lonely journeys to map vast areas of the seabed with incredible precision. Using sonar and other sensors, they create detailed three-dimensional maps of underwater mountains, canyons, and hydrothermal vents. These robots are powered by sophisticated artificial intelligence, allowing them to make their own decisions. If they encounter an obstacle, they can navigate around it. If they detect something unusual, like a chemical signature that might indicate a new vent field, they can pause their mission to investigate more closely, all without a human telling them what to do. Together, these two types of robots form a powerful team. The AUVs go out and find the interesting places, creating the maps that guide the next stage of exploration. Then, the ROVs are sent down to the specific sites of interest for a closer look. It is a wonderfully efficient partnership. The robots are equipped with an array of scientific instruments, from sensors that measure temperature and salinity to chemical analyzers that can taste the water. They are our tireless proxies, venturing into the eternal night and bringing the wonders of the abyss back into the light for all of us to see. So why do we need these brilliant robots? Why can't a person, even the most experienced diver, simply explore the abyss? The answer lies in one simple but incredibly powerful force pressure. Here at the surface, we live at the bottom of an ocean of air and we barely notice its weight. But water is much, much heavier than air. For every 10 meters you descend into the ocean, the pressure increases by 1 atmosphere. In the deepest parts of the ocean, like the Mariana Trench, the pressure is over 1,000 times greater than at the surface. It is the equivalent of having 50 jumbo jets stacked on top of you. This immense crushing pressure is the single greatest barrier to human exploration. Our bodies, which are mostly water, are not easily compressed, but the air spaces within us, our lungs, our sinuses, our ears, are a different story. Without the protection of an incredibly strong vehicle, the pressure would instantly crush a human being. Even our most advanced military submarines are not designed to withstand the forces found in the true deep sea. Building a submersible capable of carrying people to these depths is an immense technological challenge, requiring materials like titanium and specially engineered spherical hulls to distribute the pressure evenly. Beyond the pressure, there is the cold. The sun's warmth only penetrates the top few hundred meters of the ocean. Below that, in the abyssal zone, the water temperature hovers at just a few degrees above freezing, typically around 2 to 4 degrees Celsius. This relentless cold would quickly drain the life from an unprotected human. Any vehicle, robotic or crewed, must be heavily insulated and equipped with powerful heating systems to keep its internal components functioning correctly in the frigid darkness. It is an environment that is constantly trying to freeze you. And finally, there is the darkness. Complete, total, and absolute darkness. Sunlight is completely absorbed within the first 1,000 meters of water. Below this point, known as the midnight zone, there is no light whatsoever, except for the eerie glow produced by living creatures. Navigating in this environment is like trying to find your way through a vast, unfamiliar landscape in the middle of the night with no moon or stars. Explorers are entirely dependent on the technology they bring with them, using powerful lights to illuminate small patches of the seafloor and sonar to see the terrain around them. It is a world of profound isolation. What our robot explorers are finding in this high-pressure, freezing dark world is nothing short of spectacular. Life, it turns out, does not just survive here. It thrives in the most bizarre and wonderful ways. Forget what you think a fish should look like. Down here, the rule book has been thrown out. We have discovered creatures that seem to have been designed by a cartoonist with a wild imagination. How do the creatures adapt to the dark? One of the most famous is the anglerfish, a creature that has its own built-in fishing rod. A fleshy lure dangles from its head, glowing with bioluminescent bacteria to attract unsuspecting prey in the inky blackness. Then there are the fish that invent their own light. Bioluminescence is the language of the deep, used for everything from attracting mates and luring prey to startling predators. There are fish with headlights shining beams of light from beneath their eyes to search for food. There are squid that can release a cloud of glowing ink to confuse an attacker. Perhaps one of the most charming is the strawberry squid, a bright red creature covered in what look like seeds, with one large yellow eye and one small blue one. Scientists believe the large eye looks upwards for shadows of prey against the faint light from above, while the small eye looks down for bioluminescent flashes from below. It is not just the fish that are strange. The invertebrates of the deep are equally alien. We have found the Dumbo octopus, named for the large ear-like fins on the side of its head that it flaps to gracefully fly through the water. There are sea cucumbers, some of which are almost completely transparent, allowing you to see their internal organs as they creep along the seafloor. And there are giant isopods, which look like colossal wood lice, some growing to the size of a small dog. These creatures are scavengers, feasting on anything that drifts down from the waters above, and can go for years without a meal. The discoveries can also be quite amusing. Our robots have encountered squid with hairdos that look like a wild pompadour and fish with perpetually grumpy faces. One of the funniest sights is a blobfish, which looks like a gelatinous, frowning old man when brought to the surface. In its natural high-pressure habitat, however, its gooey body gives it neutral buoyancy, allowing it to float effortlessly just above the seafloor. These creatures remind us that life is incredibly adaptable and has a wonderful sense of humor, evolving into forms that are perfectly suited for their world, even if they look utterly ridiculous in ours. For a long time, scientists believed the deep sea floor was a barren, muddy desert, sparsely populated by a few hardy scavengers. But, our robot explorers have shown us that this could not be further from the truth. They have discovered vibrant, bustling ecosystems in places we never thought life could exist. Perhaps the most stunning of these are hydrothermal vents. These are like underwater geysers, where superheated, mineral-rich water bursts from cracks in the ocean floor. Around these vents, which spew water hot enough to melt lead, entire communities thrive, completely independent of the sun. Instead of using sunlight for energy, the life here relies on chemosynthesis. Bacteria and other microbes convert the toxic chemicals from the vents, like hydrogen sulfide, into energy. These microbes form the base of a unique food chain. Giant tube worms, some over 2 meters long, with bright red plumes and no mouth or gut, cluster around the vents. They have a special relationship with the bacteria living inside their bodies, which provide them with all the nutrients they need. Crabs, shrimp, and fish, all specially adapted to this extreme environment, feast on the bacteria and on each other, creating a true oasis of life in the abyss. Our robots have also revealed breathtakingly beautiful deep-sea coral gardens. We often associate corals with warm, sunny, tropical waters, but these ancient, slow-growing corals thrive in the cold, dark depths. They build intricate, tree-like structures that can be hundreds or even thousands of years old, forming complex habitats that act as nurseries and shelters for countless other species. These coral forests are some of the most biodiverse ecosystems in the deep sea, home to a dazzling array of sponges, starfish, crabs, and fish. They are fragile, delicate worlds, and our robots are the first to ever witness their silent beauty. Another surprising discovery has been the whale fall. When a great whale dies, its body sinks to the bottom of the ocean, delivering an enormous feast to the deep. This single event can create a new, temporary ecosystem that can last for decades. First, scavengers like hagfish and sleeper sharks arrive to strip the carcass. Then, a host of smaller creatures, from crabs to worms, colonize the bones, feeding on the remaining tissue. Finally, specialized bacteria break down the lipids inside the bones, supporting a chemosynthetic community similar to those at hydrothermal vents. Our robots have given us a front-row seat to this incredible long-term recycling process. Exploring the deep sea generates an unbelievable amount of information. A single robotic dive can produce terabytes of data, including hours of high-definition video, countless photographs, and continuous streams of sensor readings. For a team of human scientists, sifting through all this information would be an impossible task. Honestly, it would be like trying to find a single, specific grain of sand on a vast beach. This is where the AI part of our AI robots becomes so crucial. The artificial intelligence is not just for driving the robot, it is for helping us understand what the robot sees. The AI acts as a tireless research assistant. It can analyze video footage in real time, way faster than any human can. Using sophisticated image recognition algorithms, the AI can be trained to spot, identify, and count different species of animals. It can flag moments in the video where a rare or unknown creature appears, so scientists do not miss it. The AI can also automatically measure the size of animals, track their movements, and even analyze their behaviors. This frees up the human experts to focus on the most interesting and scientifically significant discoveries, rather than spending months just cataloging footage. Furthermore, AI is brilliant at finding patterns that the human eye might overlook. By analyzing the vast data sets from AUVs, which map the seafloor, machine learning algorithms can identify subtle geological features that might indicate the presence of new hydrothermal vents or unique habitats. It can correlate data from different sensors, for example, linking a slight change in water chemistry to a specific type of rock formation, and suggest new areas to explore. It is like having a superpowered detective that can connect clues across immense data sets, pointing our explorers in the right direction. This intelligent assistance is transforming the pace of discovery. In the past, data from a deep-sea expedition might take years to fully analyze. Now, initial results can be available within hours or days. The AI can even help to control the robot more effectively. For example, if the AI on an AUV identifies what it thinks is a new species of coral, it can autonomously decide to move in for a closer look and take high-resolution images, all without human intervention. This makes each dive more efficient and increases the chances of making a groundbreaking discovery. The AI is the brain that makes our robotic explorers truly revolutionary. The discoveries being made in the deep sea are not just scientifically fascinating, they hold the potential for incredible benefits to all of us living on land. The unique life forms that have adapted to these extreme environments have developed equally unique biochemistries. Many deep-sea sponges, corals, and microbes produce powerful chemical compounds to defend themselves or communicate in their harsh world. Scientists are finding that some of these compounds have remarkable properties. They are being investigated as potential sources for new medicines, including powerful antibiotics to fight drug-resistant bacteria and novel anti-cancer agents. The abyss is also a crucial player in regulating our planet's climate. The ocean absorbs a vast amount of carbon dioxide from the atmosphere, and the deep sea is the ultimate storage locker for much of this carbon. When tiny organisms die in the surface waters, they sink, carrying their carbon with them to the ocean floor, where it can be locked away for thousands of years. By studying these processes with our robot explorers, we can better understand how the ocean helps to mitigate climate change. This knowledge is vital for creating more accurate climate models and for developing strategies to protect this essential planetary service. Understanding the deep sea also pushes the boundaries of technology and engineering. Building robots that can survive and operate miles under the ocean requires incredible innovation in materials, science, robotics, battery technology, and artificial intelligence. The solutions developed for these deep-sea challenges often find applications in other fields. For example, the high-pressure technology developed for submersibles can be used in industrial processes, and the autonomous navigation systems for AUVs can help improve self-driving cars and aerial drones. The quest to explore the abyss drives human ingenuity forward in countless ways. Finally, exploring the deep ocean is a fundamental part of understanding the story of life on Earth. The creatures and ecosystems of the abyss provide a window into how life can exist in the absence of sunlight, offering clues about how life might have first evolved on our planet and how it might exist on other worlds in our solar system, such as Jupiter's icy moon Europa. Each new species, each new habitat, adds another chapter to our planet's biography. It is a quest for knowledge that enriches our understanding of our place in the universe and deepens our appreciation for the wonder and diversity of life. The future of deep-sea exploration is poised to be even more exciting than its present. The next generation of AI robots is already on the drawing board, and they promise to be smaller, smarter, and more adventurous than ever before. Scientists are developing swarms of small, relatively inexpensive robotic explorers that can be deployed in large numbers. These swarms will be able to work together, communicating with each other to map vast areas of the ocean floor simultaneously or to track the movements of deep-sea creatures over long periods. It will be like sending an entire army of scientists into the abyss at once. We can also expect these future robots to be even more autonomous. With more advanced AI, they will be able to conduct entire scientific missions on their own. A robot might be programmed with a general goal, such as find and study new cold seep ecosystems. The robot would then travel to a likely area, use its sensors to locate a seep, and then carry out a full suite of scientific observations, taking samples, recording video, and analyzing water chemistry before reporting its findings. This will allow us to explore more of the ocean, more of the time, without the need for an expensive support ship to be constantly overhead. There is also a move towards creating soft robots inspired by the creatures of the deep themselves. Imagine a robotic explorer that looks and moves like a squid or an octopus, made from soft, flexible materials. Such a robot could squeeze into tight crevices in rocks, move with incredible agility, and interact with delicate marine life without harming it. These bio-inspired robots could get closer to the mysteries of the deep than ever before, observing animal behavior in a much more natural and unobtrusive way. The line between machine and animal might begin to blur in the most fascinating ways. Ultimately, the goal is to have a persistent presence in the deep ocean, much like we have a network of weather satellites orbiting the Earth. We envision a future with permanent, cabled observatories on the seafloor, acting as docking stations and data hubs for a fleet of autonomous robots. These robots would patrol the depths continuously, monitoring for changes in ocean chemistry, tracking biodiversity, and alerting us to events like underwater volcanic eruptions. This next wave of explorers will transform the deep sea from a place we visit occasionally into a world we can observe and understand in real time. The journey into the abyss is more than just a scientific endeavor. It is a human adventure that connects us all. The images and discoveries sent back by our robotic emissaries belong to everyone. They reveal a part of our planet that is just as majestic and worthy of our awe as any national park or mountain range on land. These strange, wonderful creatures and hidden landscapes are a part of our world's natural heritage. They remind us that even in the 21st century, our planet still holds profound secrets and that the age of discovery is far from over. There is still so much left to find. Caring for the deep sea is crucial. Even though it is remote, it is not immune to the impacts of human activity. Pollution, climate change, and the prospect of deep-sea mining all pose threats to these fragile, ancient ecosystems. By exploring the abyss and sharing its wonders, we build a connection to it. We cannot protect what we do not know and do not love. The stunning footage of a Dumbo octopus or the breathtaking sight of a deep-sea coral garden can inspire a new generation of ocean guardians. People who understand that the health of the deep sea is connected to the health of the entire planet. So the next time you look out over the ocean, remember the vast, dark, and wonderful world that lies beneath the waves. Think of the tireless robots gliding through its canyons, their lights cutting through the darkness to reveal something no human has ever seen before. Think of the glowing fish and the giant tube worms, the grumpy-faced blobfish and the graceful octopuses. This is a world of endless surprise, and our AI-powered friends are our ticket to the greatest show on Earth, a show that has been running in the dark for millions of years. The adventure is just beginning. What will the next robot find? A new species of whale? An ecosystem that exists inside solid rock? The possibilities are as limitless as our imaginations. The deep sea is calling, and our robots are answering the call on our behalf, sending back dispatches from the last true wilderness. It is a story that is unfolding live, right now, at the bottom of our world. So, what do you say? Are you ready for the next robot selfie from the bottom of the ocean? The abyss is waiting.